हेलो डियर स्टूडेंट्स, आज का जो हमारा टॉपिक है दैट इज अबाउट मेथड ऑफ इमेजेस, राइट? सो इन प्रीवियस lecture we have discussed about what is method of images and why we use this tool to calculate electric field or some or potential at a point, at a given point, right? So let me revise that. We are saying that instead of that conductor, we are replacing that conductor in the previous topic. We discussed that if we have that conductor, so we are replacing that conductor by some charge which is placed at equidistant from the charge which is lying above that conductor. Okay. So let us so this will be clear. So we will solve this problem on this method of images. So our problem is that this a large metallic plate is placed in the xy plane. So we have this large metallic plate which is placed in the xy plane and 2 point charges. तो हमारे पास 2 point charges है, that is Q and Q, which are placed at a distance of 0 d, means this is placed at a distance of d from the metallic plate, and this is also placed at a distance of 2d because यहाँ से d होगा तो plus d. So that is why, so this charge is placed at a distance of 2d from that metallic plate, right? And one more thing, we are grounding this, so that means the total potential on this metallic surface, जो potential होगा इस metallic surface पे वो 0 होगा, right? Now, so what we have to calculate? तो हमें calculate क्या करना है? We need to calculate find the force on the charge which is placed at a distance of d from the metallic plate. तो that means हमें इस चार्ज पे हमें देखना है कि टोटल फोर्स कितना होगा. तो इस पे कौन सा फोर्स होगा? तो फर्स्ट हमें we need to understand it first. So first we know that this charge, so there will be some force due to this charge on this charge, right? And we are already saying that, so this is that, so we are grounding this, so that means the potential on the metallic surface will be 0, right? Now when we have these charges, so they will induce some negative charge on the metallic plate, right? So this induced charge, so that means we have some negative charge on this. We can have some negative induced charge on this metallic plate, right? And this induced charge will have effect on the charge which is placed at a distance of d from the metallic surface. तो that means हमारे पास जो हमारी प्रॉब्लम है, तो यहाँ पे जो फोर्स हमें कैलकुलेट करना है, फोर्स हमें कैलकुलेट करना है ड्यू टू दिस चार्ज which is placed at a distance of 2d from this metallic plate, and जो हमारा induced charge यहाँ पे होगा on the metallic surface, right? तो so the total force will be due to this charge plus the induced charge on the charge Q which is placed at a distance d from the metallic surface. तो इस पे हमें टोटल इस पॉइंट पे इस चार्ज पे हमें टोटल फोर्स कैलकुलेट करना है, राइट? तो अगर हम देखेंगे as I let me revise that. So in previous topic we discussed that if our charge distribution is not uniform, तो हमारा charge distribution यहाँ पे uniform नहीं है. We don't know how much charge is distributed, but we know that because the induced charge will be due to this charge and this charge. So we don't know how much because we don't have. So we cannot say how much charge is distributed at this point, that point, or if we have some dq amount of charge, then we can integrate this over whole metallic plate, so we can calculate the total charge induced on this metallic plate, but we don't know how much, right? So with that, so there we can use this method of images. तो यहाँ पे हम क्या करेंगे? So I can convert it. So I can put some. We have these charges. Let me. So we can write this problem that is equivalent to, we have these two charges, charge Q and another charge Q. This placed at a distance of d, at a distance of, right? Now we are removing this metallic plate, conductive plate, okay? Instead of that, we are placing some image charge. Image charge is simply if you put some mirror in front of this charge. अगर इस charge के, if you place some this mirror in front of this charge, you can have some charge which is the mirror image of this one, or also the charge which is the mirror image of this charge, and these will be at equidistant from this point and that point, from this charge and from that charge, right? So this is very clear. So that means जो हमारा charge होगा, तो charge यहाँ पे होगा, So there will be one charge Q at a distance of D. Okay. Now it's clear because तो हमें क्या calculate करना है? हमें calculate करना था कि find the force on the charge at a distance of d from the metallic surface, right? So this will be equivalent. So we are removing this conductor. We are removing this metallic conductor and we place some imaginary charges. So these imaginary charges will have their charge will be, you can say that they can have equal negative charge on these points at a distance of d below the metallic surface and at a distance of 2d from the metallic below the metallic surface, right? So that means तो इस point पे जो हमारा force होगा, so that will be due to this charge, due to this charge, image charge, due to this image charge, right? So we can write now जो force होगा, force on charge Q. ओके तो टोटल फोर्स कितना होगा सो जो टोटल फोर्स होगा ऑन दिस चार्ज क्यू ओके सपोज दिस इज सम 1 2 3 and 4 so that means force on charge which is placed at point 2 right so this will be equal to force due to this charge which is at placed at 1 plus force due to the charge may charge which is placed at a distance of 3 and so that will total force होगा because of all these charges which are placed at this point at point A at point 3 and at point 4 at point 4 point 1 point 3 and point 4 so this will be total force on this charge F, right so I can rewrite this as okay, so let us write now the total force. So first will be, you can write that force due to charge, force due to point this, due to point 1, right? So F1 will be equal to, so that will be equal to, so you can write that, that will be that Q square so this will be Q into Q, that will be Q square and this will be 4 pi epsilon naught and d square because total distance between this is d square because हमें इन दो में फोर्स निकालना है right so that will be q into q and divided by 4 pi epsilon naught into distance so distance यहाँ से लेके यहाँ तक होगा d so it will be d square so this will be force due to this one due to this charge which is placed at a point 1 and similarly if you write now what will be our f3 so force due to this charge which is placed at a distance d below the metallic plate or we can say that due to the image charge which is placed at a distance of d from a distance 2d sorry because इन दो में हमें फोर्स निकाला between this charge and between this imaginary charge image charge तो जो total distance यहाँ पे होगा that will be 2d so that will जो total force होगा and one more thing so this so direction will be downwards because these are positive charges so they will repel with each other so direction will be downwards so this gives the direction of the total force so that will be towards this metallic plate and similarly when we calculate the force between this charge which is placed at point 2 and this so now between this charge and this charge now the total distance will be 2d here because this is d and this is d so force will be equal to that is q square And similarly, force due to this charge, which is image charge, which is placed at a distance of 3D. Because यहाँ से d plus d plus d. So that means this will be equal to q square, right? Or the total force will be equal to on this charge F2. So that will be equal to q square. Okay. Okay. So total force will be equal to. So that will be equal to. ओके, तो ये हमारा टोटल फोर्स ऑफ उस चार्ज थे. तो दैट मीन्स जो हमने कंडक्टर को हमने रिप्लेस किया बाय इमेज चार्जेस, राइट? एंड बिकॉज सो दिस इज वेरी क्लियर बिकॉज जो यहाँ पे जो चार्ज डिस्ट्रीब्यूशन जो इंड्यूस्ड चार्ज मेटालिक पैलेट पे था वो हमें, सो दैट वाज नॉट नोन टू अस, right? So that is why we place some image charge and calculate the force on the charge which is placed at a distance of d from metallic pellet, right? So this is the beauty of this method of images, right? So we can calculate, so we can replace this conductor by those image charges, right? So image charges are simply you are placing some, if you put some mirror, so you can have some charges which are in the below that metallic pellet but at equal distances. So that's why I put here that so this will be at equal distance at d and 2d below that metallic pellet, right? So this is one example. So similarly you can calculate potential of this electric field at some point, or you can, so we have calculated force in this problem, right? Now the next problem is, if we calculate now, if we have this metallic pellet, so I think I will, so that I will continue in next lecture. So I will take one more lecture and I will take one more problem on this method of images. So we will discuss that in next lecture.